Alright, welcome again to section 5.6D, last one. We're going to talk about multiplying polynomials, and we're going to talk about geometry applications, or geometric applications. And this is kind of the reason why we study this. When we started our videos today, or videos for 5.6, multiplication of polynomials, I talked about, oh, you know what, here's my pool. I just got a pool. It's 50 foot by 40 foot. And what if I wanted to add a deck all the way around my pool? How much space would the total of the pool and the deck take up? Well, let's talk about the application here, because that's what we're going to talk about, the applications to geometry. So let's get some space. I'm going to go down here past all the stuff that we've done, stroll down memory lane and say, you know what, here's my pool, my beautiful pool. And I'm going to say, I've got the pool here, and I want to add a deck all the way around it. I want to say I want to add X feet all the way around it. So now I'm just going to draw something like that. And the dimensions of my pool are 50 foot by 40 foot. And I want to say, what are the dimensions of my pool plus my deck? Well, if I want to find out the area, remember area of a rectangle, area equals length times width. So here would be my length, here would be my width. My length then, if I'm looking at just the pool, it would be 50 times 40, because that would be my length, that would be my width. 50 times 40, 2,000. But now I want to say, well, how much is that the pool plus the deck going to take up? Well, I'd say I want to add 50 foot plus x around the outside. Actually, that would be probably 50 plus 2x, because I've got x on each side. So now I'm going to say this would be 50 plus 2x. This would be 40 plus 2x, because from here to here, that would be x distance. From here to here, that would be x distance. But from here to here is x. From here to here is x. So it would be 40 plus x. It gives me 40 plus 2x. So what's the total area of that pool plus the deck? Well, the length would be 50 plus 2x. Length would be 50 plus 2x. Width would be 40 plus 2x. And what would be the total area of the pool plus my deck? Well, here's the definition. We now, from here, we'd have to say, I've got now a polynomial, which is a binomial, times a polynomial, which is a binomial. And with binomial times binomial, we can use that F word, and FOIL. So we take the first, outside, inside, last. So again, if we're gonna do the FOIL method, we use the first method. First terms are these two terms. There's the first. Outside are these two terms. Inside are these two terms. Last are these two terms. So let's go through and multiply the first, outside, inside, and last. First is 50 times 40. Well, that's easy. There's 2,000. That's my original pool size. Outside terms are 50 times 2x, which would give me plus 100x, because it's plus 50 times plus 2, plus times plus. If we talk about, my method was take the signs, take the numbers, take the variables. So sign would be plus times plus is plus. 50 times 2 is 100. X times 1 is x. Let's see. Now we take a look at the inside terms. Again, positive times a positive, positive. 2 times 40, 80. And then x is the variable, x. Alright. A little bit cleaner there, sorry. And then the last one is 2x times 2x is positive times a positive is a positive. 2 times 2 is 4. X times x is x squared. And now the last thing we have to do is just kind of look at like terms. Do we have any more like terms that we can combine? We sure do. Those two terms underlined are like terms, because they have exactly the same variable to exactly the same power. So the last thing is just to combine like terms. I've got 2,000 plus 180x. 100 plus 80 gives me 180x plus 4x squared. And that polynomial as a product is an application of geometry, but it also describes exactly how much space, how much area my pool plus deck would take up. The pool would be the original 2000, and then the additional stuff would be 180x plus 4x squared. And there is the description of how much the pool and the deck would take up. All right, there's an application to geometry.